Hey guys, in this lesson we would understand how to evaluate limits using algebra. Now to evaluate limits using algebra, the question has to be given in the form of an algebraic expression. The algebraic expression could be in the form of a polynomial expression, a rational expression, algebraic expressions with radicals, and many more. To evaluate the limit using algebra, the first step is to use direct substitution. In case direct substitution does not work out and it is not able to give us a solution, then we use different methods to evaluate the limits. Let's first understand what is direct substitution and how we can use that to evaluate limits. Let's take up the first example where we are supposed to find the limit x approaches 2 for 3x over x squared plus 2. We notice this is a rational expression. Before doing direct substitution, we need to understand different properties of the limits. The first property of the limit says, if we are determining the limit x approaches to any number, here the number is general number a, and we are given function in the form of a constant k, then the limit value is k itself. For example, if we have to find out limit x approaches to 2 for a function that has a constant 3, the solution is 3 itself, no matter what is the x value approaching. Second property says, if we are determining limit x approaches to a for any variable x, then the solution is a itself. For example, if we are supposed to find the limit x approaches to 2 for x, the solution is 2 itself. The third property of limit says, when we are supposed to find the limit x approaches to a for a function that is added to another function or a function subtracted with another function, then the limit can be found as limit x approaches to a for the first function plus or minus limit x approaches to a for the second function. Example for this is limit x approaches to 2 for 3x squared plus 2x can be written as limit x approaches to 2 for 3x squared plus limit x approaches to 2 for 2x. Since we notice a constant value attached to the variable, here also we notice a constant value attached to the variable, there comes the fourth property of the limits. That is, if we have a limit x approaching to a for any function that has a constant c attached to it, the limit can be found out by taking c out as a common factor for limit x approaches to a of fx. Example here is, if we have to find out limit x approaches to 2 for 3x squared, we can write down the constant that is 3 here outside, and we can write on limit x approaches to 2 for x squared. Fifth property of limits is, when we have limit x approaches a for the product of two functions, then we can individualize the limits by rewriting the question as limit x approaches to a for fx times limit x approaches to a for gx. And the solution for each limit will be then multiplied. Next property is when the two functions are dividing each other. That is limit x approaches to a for a function fx divided by function gx. We can again individualize the limits by writing as limit x approaches to a for fx divided by limit x approaches to a for gx. The seventh property is limit x approaches to a fx to the power of n is same as limit x approaches to a fx the whole thing as a power of n. Let's understand the application of these properties with the help of examples. Going back to the first example that we started, we notice this is written as limit x approaches to 2, 3x over x squared plus 2. So we can apply the limits for a function divided by another function. And this can be written as limit x approaches to 2 for 3x, the whole thing divided by limit x approaches to 2 for x squared plus 2. Since we notice here that there is a constant, so we can take this constant out and we can rewrite it as 3 times limit x approaches to 2 for x, the whole thing divided by, here we have a function added to another function, so we can split it up using the sum rule. Limit x approaches to 2 for x squared plus limit x approaches to 2 for 2. Now we can simplify using direct substitution as well as the properties of limits. So the direct substitution says that Wherever we see x, we're going to substitute that for the number. We notice here in the second property, where we're supposed to find the limit x approaches to a for an x, the answer is a itself. So here my a is 2, so we're going to sub that 2 here. We have 3 constant outside, so we would have 3 times 2. This is limit x approaches to x square, so we're going to do direct substitution and we get 2 square. This is the first property where you're supposed to find the limit x approaches to 2 for a constant, and the rule says it's the constant itself. The final answer that we get is 3 times 2 is 6 divided by 4 plus 2, which is 6 divided by 6, that's 1. And this is the solution for this limit. Let's take up another example where we're supposed to find the limit x approaches to -1 for x to the power 4 plus x to the power 3 plus x to the power 2. This is a sum of different functions, so we can apply the property of limits that is applicable to the sum, and we can write it as limit x approaches to -1 for x to the power 4 plus limit x approaches to -1 for x to the power 3 plus limit x approaches to -1 for x to the power 2. And now we can just do direct substitution. In place of x, we're going to put in -1 to the power of 4, here -1 to the power of 3, and in this case we have -1 to the power of 2. This would give us a 1, this would give us a -1, and this would give us a 1 again. When we simplify it, we will be left with just 1 as the answer. Let's do one more example for a better understanding. If we are supposed to find limit x approaches to 9 for square root x plus 1 over root x, the whole is a power 2. We can apply the power property of the limit, where we can rewrite it as limit x approaches to 9, where we can rewrite it as limit x approaches to 9 root x plus limit x approaches to 9 1 over root x. The whole thing would have a power 2. Now we can just do direct substitution. So we can rewrite it as square root 9 plus 1 over root 9. The whole thing would have a power 2. This gives us 3 plus 1 over 3. Whole is power 2. Because this is a fraction added to a whole number, we can rewrite it as 3 over 1. To make the denominators common, we would do 3 times 3 over 3 plus 1 over 3. This would give us 9 over 3 plus 1 over 3. And finally, we would get 10 over 3 squared, which is 100 over 9. This is the solution for this question. And that's how we use direct substitution and the properties of limits to calculate limits.